So I'm really happy to present Alexandru Dejanu from Systematic. This is our last speaker from Atlas One today. And I'm really curious about this title with Ops Conservation and all the information that he will give us today. And Alex, the floor is yours. Good luck.
Cool. Well, first and foremost, thank you all for being here. I will keep it a little bit informal due to the numbers that were in here. Also, it's a little bit of a freestyle. The presentation has not been finished completely, but yeah, we're going to see what happens. So, today's presentation is going to be a little bit more philosophical. And first, I would like to ask you, because we are a mixed bunch most probably, how many of you consider that they are doing operations on a daily basis? Please raise your hand. Cool, cool. Okay, so I don't have an agenda, I just have one important idea, and by that I mean what operations means and how can we work in this day and age in the operations field. Cool. A couple of words about me. My name is Alex. I'm a site reliability engineer at Systematic from 9 to 5, and outside working hours I like to contribute on various platforms and to share my knowledge is an overstatement, to share my experience with others. Also, I'm an AWS community builder, and that's my handle. If you have any questions with regards to this presentation, feel free to reach me. Cool. So our entry point in today's presentation is what comes to mind when you hear ops or operations. And here are a couple of answers. First and foremost, most people say, okay, it's going to be something around a SRE, a DevOps, maybe a platform engineer. But don't forget about the sysadmins, right? The OGs that started this. And what is a sysadmin, right? So if you take like a high-level explanation, right? It's that engineer that maintains our servers, does the configuration of our servers, right? It's an important part and the kernel for our discussion. Oh, okay. Now, I have a funny story. When I started working, one of my first jobs was working alongside the sysadmin. And after my 4 years in college, I had a broad understanding about operating system, in the sense that we have the kernel, which is the core of the operating system, which provides us a unified view with regards to the hardware resources, does the low-level stuff, and mainly our application will operate in the user space, and we're going to talk with the kernel via system calls. Now, with this one-dimensional view, so to say, I started working, and one of my first interactions with an operating system was with using the shell, of course, but the bash shell was one of the first one. And if you'd like to test if your friend is an OG sysadmin, just do a couple of things. For me, at the beginning, I remember my first, so to say, thing was to use cat to open files and then pipe it to various commands, right? And then, of course, if you really want to annoy a sysadmin, just try to list things without using the shell expansion, right? Globbing. And with this view of operating system and using the shell, my good friend, which was the sysadmin guy, told me like, Alex, you don't understand anything. This is not how to operate in an operating system, right? And of course, if you want to use cat, you need to understand that it's being used to concatenate multiple files, so you are not using it properly. And he provided me the view with regards that the operating system, it's actually a stack of metaphors and abstractions, right? And he told me like, okay, you have your processes, which are the instance of your application, and everything flows as a data stream into your processes. Everything from a file to even a process, it's actually a file-like API, right? You have file descriptors, so everything, it's an abstraction, and you have to learn it and to understand it. And if you think about it, abstractions are very powerful. Even Kubernetes, it's one big abstraction. Okay, you can call it an orchestrator or automatic solution for beam packaging, but at the end of the day, it's an operating system. It's one big abstraction, and it has 3 pillars: CNI, CSI, and CRI. So container runtime interface, container storage interface, and container network interface. So basically, Kubernetes doesn't really know how to run containers, doesn't really know how to consume storage. It needs these 3 pillars, right? And if you think about it, if you ever install the cluster on each node, even if on the control plane, you need to have a container runtime, right? So having this abstraction in mind, if you take a look at the CNCF landscape, you're going to see some various implementation on each pillar, right? On the container runtime stuff, you're going to see different flavors from high-level container runtimes to low-level. For the CNI stuff, or the container network interface, you're going to find different plugins like Kali, Cilium, so you might have worked with them, and now you're going to see them exactly. And last but not least, on the storage side of things, you can have your own storage flavor, your own storage class, right? So these are some beautiful abstraction. And if you ask yourself, okay, how many abstraction do you operate with? Around 200. So this is the CNCF landscape, and pretty much every small square in here, it's open source technology. Most of us are working on a daily basis with all the technologies in here, and you can mix and match with regards to this technology with whatever you would like and need. And then I started to understand and see abstractions, right? And okay, basically you can say an abstraction is the fact that I'm not going to read the documentation, but at the end of the day, abstraction, it's a very powerful concept. And for me, one of the, let's say, key moments was when I understood that actually containers do not really exist. So containers are just a serialized file system bundle that we unpack and run on our machine, right? And from a high-level point of view, we need to have in our container image three things: our code base, our dependencies and configs, and last but not least, the runtime that we need for our application. But then again, I said it's an abstraction. And we're going to have another definition, a technical one, right? An ordered collection of root file system changes and the corresponding execution parameters to use within the container runtime. Now, I have a small demo for you just to have a quick view of, with regards to this abstraction. Please take it with a grain of salt. It's not something that you need to do, but just to showcase a little bit the abstraction behind the containers, right? And now, I'm going to have a small lag due to the network connection, but we're going to start very, very simple. Can you see it? It's okay for you? Do you want to make it bigger or a different color? Perfect, okay. That's an overstatement. Cool, so we're going to start simple. I'm going to create a simple file, let's call it test, and here, of course, we need to specify our shebang. I'm going to use Python runtime, and of course, we're going to do a simple hello world. And I'm going to do lots of typos, but that's not the important thing. Of course, we need to make it executable. And we're going to test it to see if it runs. It's our simple application, one-liner. Now we need to containerize it. And we're going to use a simple Docker file. We're going to take a look. And we have our runtime, some metadata where we don't have dependencies, right? So we are not installing anything in the container. We are copying our code base, and last but not least, here I hope you can see, it's actually our entry point. Can I do this? Is better? No, not at all. I'm losing time right now. Not. But you got the idea. It's a simple Docker file. Now we're going to build our image. I'm pretty bad with namings. Let's call it foo. And basically, we have our build context here. We pass the Docker file, and we have our nice and small image, which we called it foo. Let's take a look at it. And it's a Docker images. And let's take a look at it. And you can see it's a fresh image built 20 seconds ago. Now, we can leverage Docker a little bit and save our image as a tarball on our machine. Let's call it like this. And now we can peek a little bit behind the scenes. So basically, we serialized our image on our machine. It's an archive. Let me create a small directory for it. And okay, and let's extract our archive in our new directory. And if we change directory, now we extracted our tarball. It looks like this. We have a couple of things, but for us, the important part is the manifest created by Docker. And here, we have lots and lots of things, but for us, one important thing is this blob here. And we're going to take a look at it and just play a little bit with him. Now here, I know it's a wall of text, but just have a little bit of patience. We're going to take a look at the entry point, right? We know that this is the executable part, so to say, of our container. And we're going to use another binary. Let's change a little bit the message here. I know, Cloud Native Days row. And also, I like to play a little bit with the metadata, just to showcase you another thing. Oh. And now we're going to save it. And guess what? We need to recreate our archive. Oh. And let's call it YOLO.tar. And we need to do this. Cool. And now we have our new archive. And let me clean up a little bit. So our image is full, and now we can use Docker to load our new image in here. And now we didn't modify exactly the container or something with regards to the Docker file or things like that. But if we do a couple of things, first and foremost, if we take a look at the image, now we can see that the image has 34 years. This is not true because the Docker engine is not that old. And also, if we rerun once more our image, and here we can use foo, we can see that we modified the behavior of the container without modifying the Docker file. And even more, our file is there, so if we take a look at the entry point and modify it, we can see that our code base is there. So basically, I just wanted to showcase that actually containers are a powerful abstraction based on the fact that we use serialized file system bundles. Now the next point is feedback loops. So basically, what's a feedback loop? Feedback loop is a simple concept that states you're going to redirect the output in the input of a system, right? And we can see feedback loops on everyday systems, and basically the family comprises of two feedback loops: the balancing or the negative feedback loops that tend towards equilibrium. So if you think about a thermostat, and then of course we have the reinforcing, the positive feedback loops that amplify changes. So what it means for us exactly? On the negative side of things, right? The feedback loops that tend toward equilibrium, we have the reconciliation loops in Kubernetes. All the controllers that are there are actually some small feedback loops. Then again, with regards to auto-scaling, there's another feedback loop with regards to circuit breakers, because we would like to maintain the state of our system, right? And on the other side of things, on the reinforcing or positive feedback loops, we have social networks. You might have those at, I don't know, your workplace. You're going to tend to have a good interaction, and you gravitate towards a particular colleague because you're going to have a good feedback loop with him, right? And last but not least, if you think about the open source projects, all of the CNCF stuff, it's also one big feedback loop. As soon as a project has more contributions, it will become more stable, and it will be more adopted in the community, right? So feedback loops are rather important. And if you think about it from a high-level perspective for the software development lifecycle, what's the simplest flow or the regular flow? You're going to have your local environment. Most probably, you would like to share with some other colleagues, and you would like to version it. So therefore, you're going to have a version control system. You're going to have a build server, which will do a checkout of your code base. Then in the second part, you want to build your artifact and to ship it to an artifact store, and in the end, to deploy it on different environments, being development or production. And now here, if you don't get the hint, we have lots of feedback loops. If you think about it, whenever you push a change, you have to wait and see exactly if you broke anything or if the test passed. If you want to deploy your code base, right, your artifact, you need to wait and see exactly what what's the answer from the system. And last but not least, in this day and age in which we went to the microservices architecture, basically we split the monolith by from having function calls in the same code base to having calls over the network via, I don't know, remote procedure calls, REST mainly, and different message queues or brokers, right? So here you're going to have once more a big feedback loop when you're going to, I don't know, debug something, and you're going to have some observability and tracing and these kind of things in your cluster. And last but not least, this is a, I don't know, nice code which I like it. A distributed system is one in which the failure of a computer, here you can use microservice, you didn't even know it existed, can render your own system unusable. And this is highly, highly true. Now, talking about feedback loops, if you think about in terms of the evolution of feedback loops, right? When we started, at least when I started, for me the deployment process was doing an SCP to a certain server, and then, I don't know, configure the application server and doing some manual stuff, so to say. And one big achievement was, okay, someone said, let's use rsync instead of SCP. That was a big improvement at that point in time, and it just made the feedback loop a little bit better. But then, now, a big thing was when people observed and said, okay, we can leverage the version control system and represent our entire state as a commit. And then we had different things, like, since we have everything in a declarative nature as manifest, we leverage and open the world to different things. CI/CD, like the old school DevOps with that everything started with. And then, of course, thinking about custom controllers, right? Having those feedback loops inside the cluster. We started to make custom operators, if you think about like Flux or Argo and things like that. And we achieved GitOps, right? So once more, everything is about feedback loops, the response from the infrastructure. And your own experience when it comes to the response that your infrastructure will give you as soon as you're going to start to deploy something or to build something. And here also I have like a small demo just to showcase exactly what it means in terms of deploying stuff and having a response coming from your infrastructure. So, can you see it? I think I have maybe like this. It's better like this? Okay, let's start once more. Cool. So I have a simple Kubernetes cluster with no resources, right? And we're going to start very, very simple with a small script application, which basically it's a web app that we would like to deploy it in our cluster, right? Nothing fancy. And for this, I'm just going to leverage a little bit the imperative side of things and use a small plugin which I've created, and here we have various options. And we're going to start with some vanilla operations in which you need to specify the repository name. I will use Docker Hub as a registry. I'm going to call it go hello. As a tag, I'm going to use the default one. And the current workload runs in the cluster. No, it's vanilla. We don't have anything in the cluster. And we've created our deployment. And of course, I would like to expose our workload, meaning create a small service. It will ask me, okay, which workload would you like to expose it? Since I have one, just one workload, it's represented here. And let's do it to see if we have our web app. And currently, it's a small web app. This is our beautiful application, and it has this nice endpoint, right? And now, on a daily basis, what we need to do? Usually we create a feature, we modify the code base a little bit, and we wait the infrastructure or the solution or our pipelines to respond to us. And we're going to do just that and modify our code base, and our modification is going to be very important for us, meaning that this static file is going to be like this. 1 second, I just want to be sure that that's the name of the file. Yes, it's real. And now, we're going to leverage also the plugin. And here we're going to have another feedback loop, right? Because we need to build an image and deploy it in one go. And we're going to have a scratch ops. And here, is the same repository. I would like to, I don't know, modify the tag. This is coming from me, don't worry. It's part of the experience. And now we're building the image in real time, and it's going to deploy it in the cluster. It's currently running. Yes, it's running. Is the go hello deployment. And here what we can see, first and foremost, we have a little bit of color. So this was the old tag. This is the new tag that we built. It's not very visible, but it's 0.1.9. And here, the change is real. We have a gopher, a real gopher, right? So we've seen that we modified the feedback loop. We made it a little bit smaller, right? And coming back to our presentation, what I'm trying to say right now is that apps are very specific to organization and to people, right? No two apps are the same. An application can be a binary in a VM, or I don't know, a binary in a pod orchestrated by Kubernetes, or even a serverless thing, right? Some lambdas and things like that. And ops, it's all about recognizing the feedback loops, right? In all the chain, you're going to encounter many feedback loops, some of which of technical nature, some of which human nature. And as we've seen, the feedback is not really immediate, it's not instant, right? And at the end of the day, if you remember the entire CNCF landscape that we've seen, right? We have the entirety of tools, and we can play with those. We can mix and match. We have like a plug-in approach. And I don't know, the DevOps are going to start with that side of things and choose some different tools. And then you're going to need to align those, right? Because you want to have a standard in your organization. And last but not least, you're going to need to manage that, maybe with some site reliability engineering, and to manage that feedback loop with regards to the stability of the platform, right? And at the end of the day, I would like to say one thing: do not get attached to a certain technology. Do not identify with a certain technology or framework, because that's not the purpose. At the end of the day, the operation side of things, it's like one big superposition, and we're going to maybe have a different coefficient, a different side of flavor with regards to your daily job, right? So do not get attached to a certain technology. Do not just try to be one with a certain, I don't know, technology or stack or things like that, right? So that's from my perspective, the most important thing. That was it. Thank you very much for your time. I think I'm on the time. Cool.
Thank you also, Alex. That was a cool presentation, an energetic one.
Oh, okay. I can say so.
Cool. If you have questions for Alex?
If not, we're going to find each other here. So yeah, it was a long day. Cool. Thank you very much, guys.